Propulsion systems are really complex.
Liftoff. We have liftoff.
Because the payloads that we're lifting into space are very heavy, we have to break free from Earth's gravity, and that's a really difficult job. It requires large, complex propulsion systems that all have to work together to achieve our mission.
Good ignition on the second stage.
The Apollo missions really laid the framework for what we're doing today.
What do you know about that?
The F1 engine was perfect for the Apollo missions. A lot of the heritage of the F1 has been inherited by the next generation of engineers, and we're using a lot of those lessons in our systems that we're building to move forward. With our current mission at NASA, we have developed a system called the Space Launch System, which is a human-rated launch system that is going to help us to get to that next step and carry us into the future. We're going to send humans to the moon. We're also going to send humans to a lunar orbiting platform and also eventually onto Mars. We were looking for ways that we could get some hands-on experience, really dig in and find out how this engine actually worked. Even though the engines that we're using on SLS are a little bit different from the F1, they still rely so heavily on the lessons that were learned back in the Apollo days.
This is 50-year-old hardware. It's been sitting around and we refurbished it, not having all of the exact materials that they used in the past, so having to go find similar type of materials to put in the valves and test those out. It's one thing to look at it in a textbook. A lot of the designs for the F1 engine were in my propulsion textbooks, so you can see the cutaways of the valves, you can see the cutaway of the pump. But to actually get your hands dirty and look and hold each one of these pieces and then apply some of the new tools that we have today.
Here's the gas generator that we tested.
Right, and so it's cleaned and ready for hot fire testing.
So to really understand how this system worked, we took the gas generator out of a mothball state and we took it over to the test area to crank it up to see how it works.
We tried to make the injector go unstable. And we thought that, okay, surely this thing is going to go unstable because of all the work that was done in the past. And then, when we tested it, sure enough, it stayed stable and perfect. The engineering and the expertise that was put into solving that problem during the Apollo program, they really had that figured out, and it was going to be safe to fly. When we took this engine completely apart, all the way down to the bare bones, we scanned each individual part with the new technology, which is structured light scanning. And so from that, we're able to regenerate a 3D model of each individual part, and then take that and learn even further about how they were manufactured and designed. Once we have that knowledge, then we can go look at, okay, what do we want to go do for the future, and incorporate that into new designs.